Okay, let me share the slides with you guys. Okay, can you guys see the slides? Is it available?
Started, I can see.
Okay. Okay, so last Tuesday we have started a little bit on chapter 3, salts and chloralkali industries. Today we are going to go through in details, probably on caustic soda and production of caustic soda. So the chloralkali industries, as you know, this actually deals with the production of caustic soda, soda ash, and also chlorine. Caustic soda, for your information, the chemical formula is noted as NaOH. Soda ash, sodium carbonate, Na2CO3, and chlorine gas, of course, Cl2. Right, so as I said, it has been ranked closer to sulfuric acid and ammonia in magnitude due to the large consumption in various industries. Part of the uses, of course, for the production of soap, detergents, fibers, plastic, glass, petrochemicals, pulp and paper industries. Of course, the importance of chloralkali industries, as mentioned earlier. Okay, and then for the first chloralkali product, which is the caustic soda, normally produced by causticization of soda ash with lime. Okay, sodium carbonate react with calcium hydroxide to produce sodium hydroxide plus with calcium carbonate. The only problem is that for causticization process, it's only produced around 10% of sodium hydroxide. So there will be like a challenge in industries how you can actually increase the amount of product with low consumption of reactants or raw materials. That is why the most popular methods these days is by using electrolysis of brine. Brine basically is seawater, meaning that NaCl will be used as a source to produce caustic soda. Right. Okay, so for manufacturing of caustic soda, basically it is from electrolysis of brine. Okay, and actually during the process, okay, the brine will be used as a raw materials and other products or byproduct will be produced. For example, chlorine gas will produce at anode, hydrogen gas along with sodium hydroxide will be produced at cathode. There are three types of electrolysis cell that exist for the production of caustic soda. This one is quite important for you guys to remember. The first one is known as Mercury Cell, second one is known as diaphragm cell, and third one is known as membrane cell. Okay, and for the raw materials, of course, the electrolysis of brine requires only brine, which is NaCl solution, including electricity, electrodes, and container and a cell. So for the cell type, previously mercury was most widely used. Due to the health and environmental problems, mercury discharge in nearby waters, this actually need an improved design of membrane cell and a cheaper purification techniques that reduce the cost and improve the efficiency. So this will be the preferred cell used for the electrolysis of brine. The methods that use mercury is basically known as Mercury cell. Okay, right. So this the first method that is normally used. Okay, right. Let me changes into pen. Right. Okay. Not sure whether you can see it clearly or not. Okay. You can see that over here is the saturated brine solution. NaCl will be pumped into this electrolytic cell, and this electrolytic cell is made from titanium anode. So this anode is titanium anode. Okay, and then the cathode, okay, used for the process is known as mercury. You will see over here that sodium mercury is known as cathode. Okay. So basically, during the process, okay, brine solution will be pumped into the cell, and then the first reaction, okay, which basically compose the composition of amalgam. Okay, so because amalgam or the mercury electrode is made from sodium mercury, and water is actually coming from the brine solution, because this is an aqueous solution of brine, so you have water also. And what happened, the first reaction is actually the production of soda hydroxide plus with hydrogen gas and mercury. Right. So the details as follow. Okay. For mercury cell, okay, there will be no diaphragm, no separator. Okay. And the types of electrode used for mercury cell, cathode will be used from mercury, and then graphite or titanium will be used as anode. Right. So this electrolysis actually produce amalgam, and then the amalgam will be decomposed to produce soda hydroxide. Right. So basically, this is the detail. Probably this one you can see it more clear. Right. So you have a saturated sodium chloride solution. Okay. So it goes into the cell. Okay. And then when it goes into the cell, what happens is the NaCl solution will be dissolved and forming separate ions like sodium plus, Cl minus, H plus, and OH minus. This will actually the types of ions that you will see inside the electrolyte. So chloride, okay, the chloride ions that has been dissociated into the cell will attracted to the anode, and then the reduction process, okay, the reduction process of chloride, okay, into chlorine gas will be formed. Okay, so that is why over here you will see that chlorine gas will be formed at anode. All right. So what happened with hydrogen? Okay. So hydrogen, okay, later on forming the hydrogen gas. Okay, still from the chamber, but the other parts, okay, that you can see the Na plus, the sodium ions will discharge at cathode to form soda amalgam. Okay, earlier we say that your cathode will be a pool of mercury. So when mercury reacted with sodium plus, it will produce amalgam. So this is actually the amalgam. So the amalgam will be used okay, together with water to form sodium hydroxide. Okay. And this is actually the equation. Right. So sodium hydroxide okay, can be extracted okay, from here, and then hydrogen gas later on as the byproduct can be separated too, okay, and the mercury can be recycled back into the cathode. Okay, so this design, the cell design, probably you need to understand and you need to memorize so that later on during exam, if I ask you explain how you can produce caustic soda by means of Mercury cell, then of course you have a drawing, you have the equation that is related with the formation of uh, chlorine gas, the formation of amalgam, and also amalgam reacted with water to form caustic soda. Okay, any questions so far?
Sorry, doctor, for interrupt.
Yep.
Someone in the group asked doctor to admin them to the class.
Okay, all right. Wow, okay, yeah, maybe they have missed it. Mercury cell now is no longer being used in industry. Not much industries that produce caustic soda concentrates on mercury cell anymore because the reason why is the use of mercury. So mercury, you know that it is quite harmful to the environment, and most of the chlor-alkali industries, the factories and everything um, is built in, I mean, near to the seaside because you need brine solution as your raw material. So the cheapest way how to get brine is actually coming from the sea. Okay? So when you have the production of amalgam and also mercury, and after a certain while, this material will be discharged. Okay? And what happened is that when you have mercury disposed or discarded into the sea, then this will be a threat to the marine life and even others. So that is why I think if you notice long time ago, there's an issue in Penang. They said laksa that contains mercury, cockles. Cockles ni, I think in Malay it means kerang lah. Kerang yang you selalu makan tu, kerang bakar. Cockles. If you eat too much of cockles, then they say that you are eating too much of mercury. So reason why? Because I think like cockles and some fish, ikan yang digunakan untuk buat laksa tu, okay. Normally in Penang, it is, I mean, heavily exposed to heavy metals, okay? Because in Penang we are surrounded with semiconductors industry. They just discharge things into sea or into the river, and after that, the river will goes into the streams and to the sea, and it will be later consumed or exposed to the marine life. Then that is why, I mean, you will see that some of these like marine life, cockles, fish, turtles, and whatsoever will be exposed or threatened by the presence of heavy metals. So remember, this is one of the disadvantages of mercury cell, right? Of course, the advantages of mercury cell, it produces around 50% of sodium hydroxide, okay, with a low salt content, okay. So meaning that what you can achieve over here, okay, from mercury cell, the advantages is that you can have high purity, Okay. The percent of yield normally produced from Mercury Cell is around 50%. Okay, with a less or very low salt concentration. Salt concentration means that your sodium chloride and the unreacted sodium chloride will be very less. And another advantage is no evaporation needed. Okay, the other two methods, diaphragm and membrane cell, actually produce slightly lower concentration of sodium hydroxide. Then in order to increase the concentration, they need to remove out some water because the concentration produced is quite dilute. Then they will require some evaporation. Evaporation, removal of water. So when you remove water, then you can have slightly high concentration of sodium hydroxide. But of course, evaporation is always deal with cost because it's involved heating and whatsoever, right? And of course, the disadvantage of mercury cell, small loss of mercury to the environment poses a severe problem. In fact, if there's a mercury spillage in your lab, you suddenly broke your thermometers, I think you need to call like someone who are expert. I mean, to put sulfur on the spill area. You isolate the area and others. I think I'm not sure, but a few weeks ago, there's a case of a chemical spillage in our department. I mean, in our school. I think I mean, it happens during what? During weekend, and then I think the science officer or the technician have called hazmat. I think hazmat is actually not called hazwan. Hazmat. Hazmat is basically a team, a hazardous chemical team that actually managed to dispose of because they wear a proper attire with a PPE and whatsoever, and they have some knowledge on how to dispose a special chemical, especially a very toxic one, right? So I'm not sure whether you've heard about it. I mean, but a few weeks ago we have this kind of issues, right? Okay. Any question for my mercury cell before I move on to diaphragm cell? Ada soalan? Ada tak ada? Let me check if someone is waiting in the lobby. Yeah, ada. One wicket. Any question so far? Yes, no? Okay, all right. So I move on to the next cell. The second cell is known as diaphragm cell. Okay, so diaphragm cell contains diaphragm asbestos. Okay, so asbestos is basically a composite, a porous material. Okay, that actually separates anode and cathode. Okay, one of the reason is because if you look, okay, on the cell design, this clearly tells you that you have one solution in one compartment, okay, and another solution in another compartment, which you didn't actually mix it, right? So what will be the principle? So you will see over here, the saturated brine will be pumped in, okay, into anode. Okay, so it goes to anode, and your anode is actually made from what? Okay, your anode is basically made from carbon. Okay, carbon or graphite. Okay, chlorine gas is still produced at anode, okay, using the same equation as what I've mentioned to you. I think earlier there's a mistake. It shouldn't be like plus 2 electrons here. It should be plus 2 electrons over here. Then you get the chlorine gas. This is actually the anode equation. Okay. Right. So what will be the salts or the ions that will be diffused, okay, into this separator? Sodium, you will see over here, sodium will penetrate to this diaphragm, okay, and then here you have water, right? So sodium plus reacted with OH minus, and this will actually produce sodium hydroxide, okay, and hydrogen gas will be produced from here, okay. So the reaction or at cathode, okay, is basically the um, formation of hydrogen gas and also the production of NaCl, sorry, NaOH. Right. So the function of diaphragm is not only to separate the solution of anode and cathode, because over here you have like brine solution, and over here you have water. Okay, the content of ions from here to here is not really the same. That is why you need a separator, just to separate. And when you have a gradient, then that is why sodium plus can move to the other compartment. Okay, graphite anode and cast iron cathode. So the cathode used over here is cast iron, right? So the commercial anodes that is used normally graphite, carbon, ruthenium based, or platinum or iridium based coatings on titanium substrate. The most important things for diaphragm cell, the anode must be inert electrode. And the cathode, normally it use perforated steel plates or known as cast iron. The separator, it used asbestos or polymer-based modified asbestos composite. Diaphragm permits the construction of compact cell of lowered resistance as the electrode can be placed close together. But another problem is that when you have a porous diaphragm, then your diaphragm can easily become clogged. Clogged, it means that you have particles stuck, okay, attached or stuck into the diaphragm. Okay, and it should be replaced regularly. So this is part of the disadvantages because you need to replacement of asbestos. Okay. Diaphragm permits flow of brine from anode to cathode, thus greatly lessen the side reaction. And the cell with metal cathodes rarely gets clogged, okay, and operates 1 to 2 years without requiring diaphragm replacement. Okay, so this will be the reaction at anode. I think earlier I have mentioned to you that this is actually the reaction at anode. What will be the reaction? Okay, the chloride, okay, ion will be reacted to produce chlorine gas. Chlorine evolve at anode and dissolve in electrolyte till saturated. Then chlorine gas bubbles is later produced. Okay. Solubility of chlorine is dependent on temperature. Normally, it's around 95 to 100 degrees C. High concentrations of chloride ions also increases solution conductivity. So this is basically the half equation in anode at anode. Right. Another problem that you will notice for diaphragm cell is that parasitic reaction. Parasitic reaction means that any side reaction that may occur in the compartment. Okay. Often refers as anode inefficiency. This is basically due to the production of oxygen and carbon dioxide. Right. So I think for the parasitic reaction at anode, you have to know, you at least to memorize or at least to know what will be the reaction. So the first one, the cogeneration of oxygen is resulted from anodic discharge of water. Okay, since we use brine solution, so you have water, and then when it is, exposed to the electrodes, you have a tendency of hydrolysis process. So hydrolysis, it will produce oxygen and also hydrogen gas. But here, I think the most common one is the production of oxygen. The second parasitic reaction is known as oxidation of hypochlorite, OCl minus to chlorate. Right. So once you have oxygen, okay, and the chlorine, right, or the chloride ions present, you have a tendency for the formation of hypochlorite. So hypochlorite, when it reacts with water, it will form chlorate, and then later on, this will be the problem. Okay. And thirdly, the parasitic reactions will be the formation of carbon dioxide at graphite anode. So when you use graphite or carbon as anode, when it reacts with water, you will have a tendency for the formation of carbon dioxide plus with hydrogen gas. Okay, so there are three parasitic reactions that may occur at anode. Okay, so the reaction at cathode. Okay, so water molecules are discharged yielding hydrogen gas and sodium hydroxide. So this is true when we look back. Okay, so this example, I told you at cathode you will have two reactions. The first one is basically the production of hydrogen gas. The second one is actually the production of caustic soda or sodium hydroxide. Okay. Some sodium hydroxides can back migrate to anode and react with dissolved chlorine. So what will happen is when sodium hydroxides form, it still can dissociate and form sodium plus and OH minus. It can back migrate, it can goes back into anode and react with chlorine gas to produce hypochlorite. Okay, and then what happens is hypochlorite react with hydroxide to produce water, and it can also produce hypochlorous acid, which actually known as a weak acid. So this is actually part of the parasitic reaction at cathode. As mentioned, parasitic reaction at cathode can be as follows: the production of unfavorable materials. The reaction are thermodynamically favorable, but not significant kinetically under normal operating condition. Hence, the efficiency is usually high, with only 12% of sodium hydroxide, and the remaining of 15% of sodium chloride will be there. Okay. The advantages and disadvantages of diaphragm cell, you will see that the major advantage is it can run on dilute or impure brine solution. Okay, so you can use less concentrated brine without any concern about whether to use highly concentrated brine. Okay. And the other advantage is dilute brine produce around 11% of sodium hydroxide with a remaining of 15% of sodium chloride. But the disadvantage is that when you have dilute brine solution, okay, in order to make it I think more concentrated or dry, you need to evaporate it. The disadvantage first, actually it consumes lots of energy for evaporation. Other disadvantages will be for 1 tons of 50% caustic soda, it needs around 2.6 tons or 2,600 kilos of water to be evaporated. So it's quite huge. Okay, with even with very low amount. I mean, like if you want to produce 1,000 kilo or 1 ton, you need to remove out almost like 3 times of water. Okay. The other disadvantages is some amount of chloride ion remains and is highly objectionable to some industry. Okay, because the amount of chloride ions, I mean, produced from diaphragm cell, it cannot be used for polymer industry, like for example, production of rayon, due to the fact that it is less pure. Okay? It has some impurities, lots of impurity, then it cannot be subjected or used for polymer production. Okay, is it okay? Anything to ask for diaphragm cell before we move on to membrane cell? Any question? Ada? Tak ada? Right. So we will move on to the next and the last cell used to produce caustic soda. The third one is actually membrane cell. Right. The concept of soda hydroxide production between membrane cell and diaphragm cell is almost the same, except the types of separator. For membrane cell, they use semi-permeable membrane or polymer. Okay. Normally, the types of membrane used over here is Nafion. Okay. Nafion is one of the most well-known conducting polymer, okay, used in most of the chlor-alkali or energy industries. Over here, you still can see that the amount of brine used is not that concentrated. I think maybe just moderate. 26% of brine will be pumped in. Okay. Still, you will use carbon or graphite anode. Okay. The reaction that will form at anode, still the production of chlorine gas. Okay. Right. And then the sodium ion still can penetrate, okay, or passing through the Nafion to be reacted with water, because over here water will be pumped in. Okay, so you will have Na plus, H plus, OH minus. Okay, so of course H plus will be reduced. Okay, because here you still use like iron cathode. Okay, then the reaction at cathode will be the formation of hydrogen gas, OH plus 2 electron, you get H2. And then the production of sodium hydroxide over here is basically from Na plus plus OH minus to produce NaOH. Right? So the separation of compartments by porous chemically active plastic sheets that allow sodium ion to pass but reject hydroxide ion. So the use of Nafion or semi-permeable membrane actually is known as a selective membrane because it allows sodium to pass through but reject hydroxide ions. So there's no way that hydroxide ion can be back migrated or back transferred to anode. So this is not possible. All right, for the separator, it used ion exchange membrane. The examples of membrane used is actually Nephon. Nephon is a well-known conducting polymer produced by DuPont. Okay, and then other types of membrane separator can be a complex copolymer of sulfonated tetrafluoroethylene (TFE), okay, perfluorovinyl fluoride, okay, and perfluorovinyl ether. Other than that, okay, you can also have like perfluorocarboxylic acid membrane. So this is part of the examples of the membrane that commonly used for the membrane cell. Right, reaction at anode and cathodes are the same as in diaphragm cell. I think as what I told you, the reaction at anode produce what? Produce chlorine gas. Okay, and then at cathode, it produce hydrogen gas and also sodium hydroxide. However, the sodium ion from anode are exchanged by cation exchange membrane to cathode to form sodium hydroxide with hydroxide ion OH minus produced at cathode. In theory, pure caustic up to 50% of concentration can be produced. This actually slightly better as compared to diaphragm cell. Practically 10 to 35% are obtained depending on nature of the membrane and operation condition. The advantages of membrane cell: the purpose of membrane is to exclude hydroxide ions and chloride ions from anode chamber, thus making the product far lower in salt than that from the diaphragm cell. Membrane cell operate using more concentrated brine and produce purer and more concentrated product. It produces around 30 to 35% of sodium hydroxide. Okay, so if you still remember how much amount of sodium hydroxide produced from Mercury cell, anyone still remember? Afikah Jamal. Afikah Jamal, are you around?
Ya, doktor.
Okay, so how much amounts of sodium hydroxide produced from Mercury cell?
50%.
50%, okay.
Yes.
Right. And then Devyasri Sinaya, how much amount of sodium hydroxide or caustic soda produced from diaphragm cell? Devyasri, are you around? Cannot hear you. Okay. Lee Boon Kit, are you around? Boon Kit?
Yes, sir.
Yeah. So how much amounts of sodium hydroxide or caustic soda produced from diaphragm cell? Remember? Yes, no?
No.
Okay, it's okay. Then I ask another person, Liana. Liana Syafawati.
Ya, doktor.
Dengar ada penyokong kat belakang tu. Okay. Berapa persen? How many percent?
11.
11.
Bukan lah.
No, not correct. No, Nadiha. No, Nadiha, how many percent? Cannot hear you. Berapa persen? Nampak dah unmute dah tu. But cannot hear anything from you. It's okay. Right, so the amount of sodium hydroxide produced from diaphragm cell, again, okay, mercury tadi berapa? Mercury cell produce around 50%. Okay, 50% of sodium hydroxide. And then for diaphragm cell, so diaphragm cell produce around 18% of sodium hydroxide. Okay, membrane cell produce around 30 to 35% sodium hydroxide. Of course, this will be the highest, but again, as I said, mercury is the problem. Okay. All right. So diaphragm cell is also another interest. It can actually use less concentration of sodium hydroxide, but the problem is the amount of sodium hydroxide produced is lower, and at the same time you will have around 15% of sodium chloride byproduct. Then of course you need to get rid of this, okay, and then you need to evaporate. Okay, to evaporate so that it can increase the percentage of sodium hydroxide or concentration of sodium hydroxide. Right.
Doctor.
Yeah.
Question. For the diaphragm cell, the not write 12% of NaOH.
Sorry again?
The not write the 12% of NaOH.
The sodium hydroxide, the percentage is?
For the diaphragm cell.
Diaphragm cell, okay.
12%.
12%? Really? Oh.
Bawah satu. Bawah satu slide.
Bawah satu slide lagi. Which one?
Atas dua. Bawah satu.
This one? This one?
Slide 15.
Slide 15.
Yeah.
This one?
Pass already. 14.
Okay, but yeah, here. Maybe here. You mentioned it here. 12%.
Yeah.
Okay, yeah, well, here it says, okay, my mistake. Not 18. Okay. Right, so 11%, not much. Okay, then as I said, you still have a trace of sodium chloride around 15%, and you still need to concentrate the sodium hydroxide by evaporation. So this is part of the disadvantages. Membrane cell, actually you have quite moderate amount, okay, but still evaporation is there. You still need evaporation. Okay, so you can see over here requires only 715 kilos of water to be evaporated to produce 1 megatons of 50% sodium hydroxide. So even though there's still needs of evaporation, but the amount required to remove water will be less, which means the energy or the electricity needed for evaporation will be less as well. Right. So because of the difficulty and expense of concentration and purification, only large diaphragm cells are feasible. So membrane cell produce concentrated sodium hydroxide, and it can actually considered as a saving in energy for evaporation because not much of evaporation required, and then saving in freights, okay, that operates to the point of the caustic use. It is more smaller, compact, and efficient unit that cause a revolution in the distribution of chlor-alkali industry, particularly if efficiency remain high. So most of the industry for the production of caustic soda actually concentrates on use of membrane cell, okay, in the industry. Right. So the disadvantages of membrane cell, there's still some disadvantages. The membrane are more readily clogged than diaphragm because the membrane is more finer in porosity size because it cannot allow sodium hydroxide to pass through. Okay, so it can easily clog as compared to diaphragm. So some saving are lost because of the replacement of a membrane and the necessity to pre-treat brine feed in order to remove calcium or magnesium before electrolysis. So this is basically the comparison between diaphragm process, mercury cell process, and membrane cell process. You will have advantages and disadvantages. This is actually considered important for you guys to remember, okay? Right, because all this discussion will actually normally ask, I mean, during tests or during exam. So to just differentiate what would be the advantages and disadvantages. And remember the reaction that occurs in anode and cathode must be remembered as well, right? Okay, so maybe a few slides, okay, before we call for the day. The unit operation and chemical conversion. This actually, when you want to consider chlor-alkali industries, what will be the unit operation? What will be the facilities? What will be the instruments needed and need to be installed or considered? So the first one is brine purification. Remember, in your brine solution, you still have, I mean, other chemicals like calcium ions that comes from the minerals, okay, in the sea. You can also have like magnesium and different kinds of ions that may present in your seawater. So it needs brine purification. So anyone knows how actually you can purify your brine? Siapa tahu? Macam mana? How did you perform brine purification? How do you purify your seawater? Any suggestion? Nurul Amilin? Any suggestion?
I don't know, Doctor.
Dah menyerah kalah sebelum mencuba. Okey. Po Chu Liang. I think Brian Po. Brian, are you there? Maybe no. Okay. Pui Linko. Pui Linko. Are you there? Yes, no? No? Okay. Okay, okay, doctor, my mic not functioning. Okay, I can understand that. No problem. Okay. Brine purification can be performed by using filtration. Okay, so remember I told you earlier that in your brine, you may have other things like anions, different anions. Okay, chlorides. What else? You can also have carbonate. Okay, you can also have phosphate. Okay, and many things that may actually exist in your brine solution. Apart from that, you can also have like other types of minerals. Okay. Not only sodium plus, you can also have like calcium 2 plus. You can also have magnesium 2 plus. Okay. What else? You also have potassium plus and others. So all this actually required to be removed out. Okay, using filtration, because filtration, if you use resin, okay, membrane or filter, it can actually remove out ions or also minerals. Okay, and at the same time, some filtration also having antimicrobial properties, meaning that you know that in your brine solution you may have some, microbiological living things or living organisms that you need to remove out. Okay, so some filtration also equipped with that. Okay, and you also sometimes would have dissolved gas in your brine solution. Then the use of suitable filter would be necessary to purify your brine solution. Right. So for brine electrolysis, okay, this actually consider the type of electrode used. What would be the type of electrode? Of course, you may consider like graphite, carbon as your anode, and then probably you can consider like iron, okay, or maybe other types of metals as cathode. Okay. Evaporation and salt separation, this is actually important because in order to increase concentration of sodium hydroxide, you will need evaporation. Okay, and for the salt separation, of course, if you produce sodium hydroxide at the end, how you are going to separate it? Of course, this one will be effective when you use filtration, because some of this, when you evaporate, it will become solid, and you need to remove out the solid with the liquid solution. Final evaporation, okay, the temperature and whatsoever, finishing of caustic, okay, either you can have it in pellet, okay, or in flakes. Okay, sometimes I think most of the time you will see sodium hydroxide that you can find in your lab. It is in pellet, pellet size, sometimes in flake. So how actually they produce? Because you will see that when they do evaporation, what they actually do is they will inject, okay, the solution that goes into a heater, okay, maybe heat exchanger, okay, and then what happens is when it is heated, okay, you have like a nozzle that spray, okay, that spray the solution, and when it dry, it will become powder, crystal powder, flakes, or whatsoever. Okay, so this how you actually finish off your caustic product. Okay, and other will be a special purification of caustic, okay, maybe by recrystallization. Okay, recrystallization techniques actually dissolve the salts, okay, in water, and then you dry it again, okay, to remove out any sort of impurity. Then this will be sometimes required in the industry. Right, so I believe the other parts of the brine electrolysis, okay, and the other part we can actually continue next week, and probably if you have time, you can watch the video animation. Probably next week, before we start, we can also have look at the video how the chlor-alkali process is produced. So please use your YouTube wisely. Okay? Jangan gunakan YouTube untuk tengok Nilofa pergi Langkawi ke, tengok Mami Katuri ke apa ke. So use it for educational purpose. Right. So is there any questions so far before I adjourn the class? Apa-apa soalan? Anything? Anything? Ada soalan atau tidak? Yes, no? Okay. If...
Doctor, for the
Yeah.
membrane cell, can you go back to the slide, first slide of the membrane cell?
This one?
This one. Yes, this one. Is at here is say that 26% in at the anode and 24% out. Is that mean only 2% of the sodium chloride is used?
No. Actually, if you look over here, even though the inlet of sodium chloride pumped into the anode is around 26%, okay, it doesn't mean that 24, I mean, like, of course, when you see over here, 24% of sodium chloride is expected to be produced as a byproduct as well. But bear in mind that during the process, okay, you have a tendency that this sodium ion normally, okay, this sodium ion normally, it will pass through the membrane, okay, to form sodium hydroxide. The only problem is that if your nephron or your membrane used as a separator, it has like clog because it easily clog. Then the penetration of sodium ion from anode to cathode is normally not 100% sometimes successful. It can be like maybe half of the amount of sodium ions can pass through the nephron, okay? And when it already be saturated, if it is not, I mean, like really passing through, then it just remain there and finally remove out. So forgot to tell you, okay, for membrane cell, the amount of sodium hydroxide byproduct produced is still considered high because, as I said, even though the amount of sodium hydroxide product will be like around 30%, but due to the fact that nephron is actually considered as a very fine porous material, not all sodium ion produced in anode will be transferred or penetrate through the membrane. Most of the sodium ion will be remain there, okay? And if it is not being used, it just been, I think, removed out. But this is always like in cycle. So you still, I mean, the sodium chloride solution that, I mean, that is not being used, it still can be reused again, okay? And what you need is that, okay, maybe if the amount of sodium chloride content is like almost equal or already like not much been transferred to the cathode, then of course you know that your membrane need to be replaced more often, right? So this is part of the challenge. I mean, if you use a membrane cell as compared to diaphragm cell. I mean, diaphragm cell, it is less easy to clog as compared to membrane cell. Any other question? Yes, no?
No, Doctor.
Okay, all right. So if there's no further question, then thank you very much for your kind time, and I'm very sorry for the slight delay just now. Hopefully to see you next week. I will start to post your assignment later tomorrow. Okay, and you can start to do your assignment. Your assignment one will be individual. Okay, it will be a combination of chapter 1, 2, and 3. Okay, and for the next class on Tuesday, we also will have, oh no, not Tuesday, but Wednesday. Wednesday we will have a quiz on chapter 3. Okay, or I mean perhaps chapter 3 or chapter 2. Still the same. I mean, like you will do it online, and you will submit it through the e-learning. So it has been a long day for me today. Thank you very much again for your kind attention. Hope to see you next Tuesday. Have a good rest, and Assalamualaikum. Good night, everyone.
Thank you, Doctor.
You're welcome.
Thank you, Doctor.